We're going to talk about solving rational equations, and you need to know that a rational equation is an equation that contains one or more rational expressions. Now remember, a rational expression is just a fraction. These equations are going to have variables in the numerator and denominator. Now there's a couple different ways that you can go about solving these kind of equations. If you want to get everything on each side of the equation down into one rational expression, you can cross multiply just like you were doing, just like you were solving a proportion. But that might be a little bit more work than you need to. So this next statement here is kind of what we're going to do when we solve these. Okay, and so we're going to multiply everything in the equation by the least common denominator, and you're allowed to do that with an equation. You can multiply by anything that you want so long as every single term is multiplied by that same thing. Okay, this is called clearing fractions, because when you multiply everything by the least common denominator, all the denominators are going to end up canceling, and then you're going to be left with an equation that you should recognize in solving. Now, sometimes this equation will be a first degree equation, so then it's just like any other linear equation. Sometimes it's a second degree equation, and you would have to use the quadratic equation from there, or maybe factor. So the idea is to make this into something that we're used to seeing. So since we're dealing with fractions, and fractions specifically with variables in the denominator, we have to be careful about restrictions. And this kind of goes back to the idea of domain. You're not allowed to divide by zero. So at the very beginning, what you need to do is check all your denominators, and if there's a variable in there, you take that denominator and set it equal to 0 and solve just a little simple equation. The solution to these little equations that you got from the denominators are what your variable is not allowed to be, because what you're doing there is finding what values that that when you plug into your equation would give you a 0 in the denominator. And again, you're not allowed to divide by 0. So you want to do this first, because by the end of the equation you may forget, because you're canceling all the denominators, you may forget about the restrictions at all. So you just make sure you do that first, and I'm going to go over those when we do our examples. So here's the first equation that we're going to look at. And again, the first step is to really take a look to see what your restrictions are. And again, the restrictions have to do with the denominators only. You're not allowed to divide by 0, so we have to find out which values of x, if we plug them in, would give us a denominator of 0. Now you have to do this to every single fraction that shows up, and sometimes you'll get the same answer, sometimes you won't get the same answer, but you have to find every single one. And so let's do that first, and then I'll talk about what that actually means when you find it. All you're doing is taking each denominator and setting it equal to 0. And then there's going to be these little equations that you've created that you're going to end up solving. In this case, it's very, very simple. This first one we're going to divide by 3, and we get x equals 0. And then the second we're going to divide by 5, and again x equals 0. So these are the numbers, and in this case they're the same, that if we plugged in to all of our variables, we would have trouble, because the denominators would be 0, and again you can't divide by 0. So what these are what your restrictions are. That's what x cannot be. Now this is important, because we're going to go and solve this equation, and as we go, there's a chance that the solution, when found correctly, is 0. But that can't happen in this case, on this problem, because if x was 0, we would have a situation where we're trying to divide by 0, and that's something that you can't do. So if that happened, that would mean that there would be no solution to this. But, that's just something that we're going to keep in mind and come back to. Now what we're going to do is we're going to clear these fractions. And again, we're going to do that by figuring out what the least common denominator is, and then we're going to multiply everything in our equation by that. Okay, and so you're thinking, what goes in, what do these both go into? And that would be a 15x. Now, if you don't pick the smallest one, you're kind of okay. You just might have to do some reducing later. But they need to be canceling the denominators. Now, once you get used to this, you'll be able to cancel as you go, but I'm going to write out the steps right now to show you what's really going on. So when we multiply this first fraction by 15x, that's what it's going to look like. And then the second fraction will also be times 15x. And then finally, make sure everything gets multiplied by whatever you're saying your least common denominator is. Now, be careful, and you don't want to distribute quite yet, because the whole idea of multiplying by this number is that it cancels out our denominators. So do that. If there's anything left over, then we'll end up distributing it. Okay, so in this first fraction, the x's are going to cancel. The 3 is going to cancel with the 3 and 15, and we're left with 5 times x plus 4. And now in the second fraction, the x's are going to cancel. The 5 is going to cancel with the 5 and the 15, and we're left with 3 times x plus 8. And then we do want to multiply this over here, which would be 30x. Okay, now this is a very simple equation from here. We're going to distribute in both places, combine like terms, and just solve for x. So that gives us 5x plus 20 plus 3x plus 24 equals 30x. Let's combine our like terms. We have 8x plus 44 equaling 30x. Subtract 8 on both sides, so it would be 44 equals 22x. And then we'll divide by by 22. 44 divided by 22 is 2. So now, you need to compare your answer to what you said the restrictions were. And that way, you can tell whether or not there's a solution to this equation at all. Our restriction said that x can't be 0, had nothing to do with 2. So x equals 2 in this equation, and we're happy with that. You can plug that back in to all of the variables, and it better check out on both sides. So let's take a look at this equation, and again, let's make sure we state our restrictions. This one is pretty simple. Both of our denominators that we have here are the same. So I'm not going to do it twice. It wouldn't make any sense, but we do need to figure that out. And again, when you get used to doing this, it's something that maybe you don't even have to write out the equations for, but make sure that you actually state it somewhere so that you remember what you're looking for. So x minus 5 equals 0. We'd add 5 to both sides. And so we're saying x cannot be 5. Okay, that's our restriction. So let's figure out what the solution is. Okay, and so again, you want to multiply everything in this equation by the least common denominator. In this case, it's just x minus 5. It's very simple. Okay, and again, I'm going to write out the steps so you can see what's going on. We multiply the first fraction by x minus 5. And the second equation by x minus 5. Okay, and again, the whole idea is that when we're done with this step, we shouldn't have any denominators. And so we can cancel the factors of x minus 5 in both of them. And we're left with x minus 1 equals 4, very simple equation. We're going to add 1 to both sides, x equals 5. Okay, and so we solved that correctly, but you notice that our restriction said that x cannot be 5. Because if you plug this in to all the variables, we're going to get a 0 in the denominator, which is something that can't happen. So this is the correct answer, but we actually can't really use it. So this equation has no solution. So now we have a very similar example to the previous one because our denominators are the same. Okay, but again, we want to make sure that we know what x is not allowed to be. So we're going to come over and set it equal to 0 and solve. So x is not allowed to be 3. And now let's go about solving the equation. Looking for the least common denominator. And when all the denominators are the same, this is a very simple step. So I'm just going to multiply by that x minus 3. Okay, and I can distribute it like we've been doing, but the whole idea is that this denominator and this denominator will be canceled by that x minus 3. And so then we're already left with just x squared equals 9. Okay, now there's a lot of ways that you can solve something like this. If you want to move the 9 over with the x squared, we could factor that as difference of squares. We could, after we move the 9 over, we could even plug it into the quadratic equation. But this is really easy because we can just take the square root of both sides. Now remember, we're going to get two answers here, so be careful when you're doing that. This is going to be x equals 3 and x equals negative 3. Now again, we got to check our restrictions. Because of what the denominator started out being, we know that x cannot be 3. So this is not a solution. Our restrictions say nothing about x being negative 3, so this equation only has one solution. So we're going to start off and find our restrictions, and that means we have to deal with every single denominator, and we've got to set them all equal to 0 and see what they give us. So we have x plus 5 equaling 0. So we know that x cannot be negative 5. We set x minus 5 equal to 0. And so we know x cannot be 5. We set x squared minus 25 equal to 0. Solve that. I take the square root here, and so x can't be 5 or negative 5. Okay, so we got a couple repeats, but we have two restrictions on here. Okay, x is not allowed to be 5 or negative 5. So let's just keep an eye on that. So we are going to solve this equation, and we have to come up with the least common denominator. Now, if you remember when you're simplifying your rational expressions, we need to factor all denominators first so that we can find that least common denominator. These first two are already factored, and so we better factor the third one. Okay, this is a difference of squares problem. So I'm going to rewrite these first two. And this denominator factors into x plus 5 and x minus 5. Alright, so not too big of a deal because we have some repeated factors in our denominator, so it's not going to be the worst thing in the world. But we do need to multiply everything by that least common denominator, which is x plus 5 times x minus 5. Okay. Now, you can definitely write them all out. You could write 2 times x plus 5, x minus 5, and then go about canceling. But, I think hopefully by now you get the idea of what's really going to happen. This x plus 5 is going to cancel with this x plus 5, and we're going to still have 2 times x minus 5. Now when we move to this fraction, this x minus 5 will cancel with this x minus 5, but we'll still have this x plus 5, so it would be 1 times x plus 5. Now both of these factors are going to be canceled by our least common denominator, and so we're just going to be left with 16. Again, we have a very simple equation here. We're going to distribute first. 2x minus 10 plus x plus 5 equals 16. We're going to combine some like terms, so we have 3x minus 5 equals 16. Going to add the 5 to both sides and have 3x equals 21. And finally divide by 3, so x equals 7. Again, make sure you check the answer that you get with your restrictions. Our restrictions say nothing about x being anything except for 5 and negative 5, so we're okay, and this would be our solution. Always make sure you state any restrictions first so that you can check your answer later. And this is a very simple one to look for because we only have one denominator, and it's just x by itself. So you can go over and set it equal to 0, but it's already solved. So we know that x can't be 0 here. Now we're going to go ahead and multiply through by the least common denominator, but again, very simple because it's just x. That's our only factor that we have. So when we multiply everything by x, we're going to have x squared plus 6 equals 5x. All right, now we have this quadratic. And you have a bunch of different ways that you can solve it. You have to set it equal to 0 first, so let's take care of that. And I'm going to write this in descending order. And so we have x squared minus 5x plus 6 equals 0. And now, you can always do the quadratic equation. I always look and see if it can factor, and if it's obviously something that can factor, I do that because factoring is much quicker. Okay, but you can always just start plugging numbers in, right? A is 1, B is negative 5, C is 6, plug it into the quadratic equation. However, I do know that this factors, and so I'm going to do it that way. So I'm looking for numbers that multiply to give me positive 6, add to give me negative 5, so that'd be a negative 2 and a negative 3. We'll set both of those equal to 0. Add 2, so x is 2. Add 3, and x is also 3. Check. That's not part of our restrictions, so in fact, these both are the answers. So make sure that you are factoring any denominators, and then just multiply through by the least common denominator, and it should be a pretty simple process.